So in this video, I want to talk about a couple of things. The main thing I want to talk about is the turtle module within Python. If you've ever played with turtle graphics or logo, then you're familiar with some of these concepts. One of the things that's going to give us an opportunity, it's certainly kind of fun to play around with these little graphical kinds of things. It's also going to give us an opportunity to play around with loops some more, and that's one of the issues, one of the things that a lot of introductory programmers tend to struggle with. So I want to spend a decent amount of time on that. So here I have a simple project, a basic project set up within PyCharm. And even before we start writing a file, again, I want to kind of revisit this use of the Python console. So if I open up the Python console, you'll see kind of goes through. It starts this up and everything. And again, remember, this is a live Python interpreter. Okay, so it is awesome for doing a number of things. It's awesome for when like in this case we have a new module that we want to play around with, or as you're writing your code, if you have different ideas that you want to kind of try out and all of that. Again, the console is great for doing just that. Okay, so let me first import the module. So there we've imported the turtle module, and then in terms of setting these things up and so forth, basically, we're going to kind of do the following type of process. So I can say, for instance, that I want a turtle screen. And you'll notice that when I do that, I get this large turtle screen here. Now, one thing that I will caution you on when you are interacting with this through the console, you'll notice, for instance, I'm getting this little sort of not responding. So that will happen from time to time, especially when you're interacting from the console, and there are a little bit of kind of wonkiness in terms of the communication between the two. But nevertheless, you should still be able to kind of have this function and make it do different things and so forth. So we can do a couple of things with this. One of the things we can actually set the title of the window. Okay, so I could have something like "Hello Turtle." Yes, it hasn't actually updated. Hopefully, let me go ahead, while that's kind of thinking hard and all of that, let me go ahead and create a turtle. There we go, it finally did update. Okay, so there's our turtle object himself, right? So the turtle, and turtle graphics basically was designed to kind of teach kids to be able to program, right? So we have this little turtle that almost functions kind of like a little robot, and we can basically make the turtle do a number of things. So for instance, I can tell the turtle to move forward a certain amount, and he moves forward 100 pixels. Notice drawing a line behind him. Right, I can have the turtle turn in some direction, let's say 90, right? And then again, I can have the turtle move forward, right? I can have the turtle turn once again, move forward once again, turn, move forward, and you see we've now basically drawn a square. Okay, kind of cool. Some other things that we can do. So notice I can say t.reset. So there's a couple of these. T.reset will basically clear the screen, get the turtle back to his original setting and all of that. There's also t.clear. So notice that just clears the screen. T.reset basically not only clears the screen but also resets the state of the turtle. Some other things that we can kind of play around with. So one thing I want to point out, notice I'm doing a lot of repeating here, right? So I'm basically saying, okay, move forward, turn right, move forward, turn right. So I'm doing these set of steps, these two steps, multiple times, 4 times in fact, to basically draw a square. Okay, so again, based on our reading and all, you should have a sense that, you know what, we could probably use a loop for doing that. Yes, that's fine. So again, when we talk about loops, we kind of talk about really a couple of different kinds of loops. Really, one of the big distinctions that we make is this idea of a definite loop versus an indefinite loop. And the question essentially comes down to, do you know up front how many times you're going to loop, right? So in the case of a square, well, yeah, I know that I'm going to have 4 sides. So there I have a good sense of what I want the loop to do. I have a definite loop, right? And so in that case, typically we use a for loop. So I can say for I in the range up to 4. And then here I just want to say, move forward 100, turn right 90, one more enter, and there he goes. The turtle drew my square. Okay, pretty cool. We can actually draw, we can of course draw other types of shapes as well. So for instance, I could have 4i in the range up to 3, and I can say turtle forward again. Well, actually, let's just to show that I don't have to use 100 there. I could use, let's say 150. And how about let's make left-hand turns. And so let's see. So there are 3 sides that we want, and we want it to go across the whole 360 degrees. So 360 by 3 is, I believe, 120. And there we go. We have a triangle. All right. You can also have the shape that is drawn filled in. Okay, so again, let me clear this. And, so if I go back through the stuff that I had before, basically what I want to do is, so I can do something like the following. I can say t dot begin fill. Right, so that basically says, okay, the stuff that the steps that we're going to take now are going to be for drawing a shape that needs to be filled in, and then I can do my steps for drawing the triangle, like so, and then I can end the fill, which fills that in, given the appropriate color. Right. Not too difficult. Let's talk about actually setting the colors and so forth. So there's a couple of things that we can do. I can set the pen color. Well, one, I can actually get the pen color, right? So notice if I just call the pen color method of the turtle, I get back the response that we are using black, right? I can set that. There are actually a few named colors, and actually the documentation kind of talks about the where you can kind of look up the names and things like that. But I could set the pen color to red, for instance. Notice that my turtle actually has changed to red. I can also do things like, for instance, I can set the line to be thicker, right? So for instance, now I'm going to draw a line of width 5. And so then I can again go back through our begin and end and so forth. Let's see. So what do we have? There's end fill. Yeah, there's the begin fill. There's that. And finally, our end fill. And that's, oh, yes, right. Okay, notice, it appears that it actually did nothing. Let me, once again, just go back here. Okay, so at this point, I'm kind of repeating myself a bunch, so let's actually create a little file here for us to kind of make some of this stuff, to basically kind of keep track of some of this stuff. All right, so let's just call it hello. Turtle. All right, so the various things that we did, right? So we kind of did this stuff here. And then we have our various things, like, for instance, what we've been doing. So, we had set the pen color, set the width, do all of these things. Again, let me paste those in. Right, so you'll notice that there's our basic setup. Create the screen, set the title to Hello Turtle, create the turtle, set the pen color to red, draw our triangle, and let's try actually running this. Now, so let me go ahead and close this. You may notice that it kind of hangs, comes up with something like this. Okay, so I can close this. That actually will have the effect of bringing down or killing my my Python console, right? So notice the process has ended. So if I want to restart that, I can do that basically here. But now that I have this program here, let me actually go ahead and run it. So if I just come over and say run Hello Turtle, right there it is. Notice that it disappears basically right away. Okay, so that's kind of a problem. And so when we have a Python program, right, in a file, if we want the window to stay displayed until we do something, for instance, click on it, we can call the exitonclick method of the window. Right, so I do that, and now when I run this, we'll see we actually get the shape drawn, and then basically the window's here. Once I click on the window, it disappears. All right. So, why, if the pen color is red, are we getting a black triangle, right? Basically because there's also something called the fill color. Okay, so the fill color is another thing that we can set. And so there I've changed the fill color to be red in both cases, and so we end up with a nice red triangle, right? Just like that. Now, a couple of other things we can kind of play around with. So again, let's talk more about. I'll continue on talking about colors. Other ways of specifying colors. I can actually specify a color. Oops, sorry. A color using basically the typical kind of triple of numbers. That is, specify the amount of red, the amount of green, and the amount of blue. Now, the only thing that you do need to be a little careful about here is by default, the amounts that you specify must be floating point numbers between 0 and 1, right? So this says full on red, no green, no blue, right? So again, if I run this, we can see, right, there is red. Okay. On the other hand, if I wanted, let's try something like this. Okay, so there we have filled this in with blue. Okay, now most of the time when we're specifying colors in other programs and so forth, generally what we actually do in those cases is we typically specify a color in the range between 0 and 255. Okay, so we can actually do that with the turtle as well. Basically what we need to do is change the color mode, and oddly enough, we actually change the color mode on the window, not the turtle itself. So we can say WN color mode and pass in 255. Now you'll see, for instance, when I run this, that looks black. Why? Because it's 0 red, 0 green, and only one for blue, rather than a full-on blue, which would be 255. Like so. Okay, so those are the different ways that we can specify colors. Now, once we get down to this level here, where we're actually specifying the raw red, green, and blue components, what this gives us the ability to do is to use or to randomly create colors. Okay, so I can import the random module from Python, and then what I can say is, okay, here I'm going to call the randint method between 0 and 256, right? So why 256? Well, if we take a look, import random help random.rand int. Okay. Actually, sorry, so I was wrong. Returns a random integer in the range from A to B, including both endpoints. Okay, so in that case, I actually do want 255. Right, so basically pick a random amount of red a random amount of green and a random amount of blue. And then we'll go ahead and run this. And so we'll see each time that we run this, we should have a different color that is being used for the fill color. Okay. Some other things. You'll notice that right now the screen kind of comes up, it's a particular size. So I may actually want to take control of that and decide that the window is going to be a particular size. And the way that I do that is I use the package level method setup. And so for instance, I could say, okay, I want my screen to be 800 by 600. Right, so when I do that, basically there, you'll notice I now have a smaller screen. Okay. Now, the animation of the turtle, you see that, the turtle is basically being animated as it draws all of these things. We actually have control over that, over the speed of that. And again, all this stuff is defined inside here, right? So notice they talk about, here's the turtle methods, move and draw, right? So different ways of moving the turtle around, its state, settings, setting and measurements, right? Draw state, etc., etc. All through that, right? So let's see, here's the speed method, and notice it says, okay, sets the turtle's speed to an integer value in the range from 0 to 10. If no arguments given, we return the current speed, right? So 10 is fast, 1 is slowest, 0 is actually fastest. So again, we can kind of play around with these things as well. So if I said, for instance, t dot speed, let's say 10, we can actually take a look and see, right, yeah, it draws actually much quicker. On the other hand, if I had something like t dot 1, slower. So that certainly is handy, especially if you're drawing very complex types of things. You don't want to wait around too long for the drawing to happen. Let's try Turtle 5. There we go. One other thing that I do want to show with this is, just like we've seen in standard Python, that it is quite straightforward to read in a value from the console. It turns out actually that the turtle module does provide us the ability to get input in a more graphical manner. Okay, so for instance, you'll notice right here that I have hard-coded in, essentially, the length of the side of the triangle, okay? I don't have to do that. What I could do is create, for instance, a variable, side length, and then I could call the num input method of the window, or of the screen, right? So this takes a couple of things. First of all, it basically takes a string for the title of the dialogue, so I'm just going to call it triangle. Then the prompt string, enter side length. Okay. And further, enter side length. Right. And let me actually show you. So for instance, if I go search for num input, right, so notice we take the title for the dialogue, we take the prompt, we can have a default value. Notice the last three are actually optional. So for instance, I could say, oh, you know what, I want a default value of 100. And it doesn't necessarily make sense to have a negative value. So, and furthermore, maybe I don't want really, really tiny sizes. Maybe I'm going to say, okay, I want the minimum side length to be 10, right? And I could even provide a maximum side length, something like 600 or whatever, or just leave that off, right? So doing this and patching it in now means when I run the program, you'll notice, okay, it says, oh, enter a side length. I can say, oh, okay, let's do 200. And there it is. Okay. So it gives you an idea of how to use that. One other thing, and that is, it turns out that actually the shape of the turtle can be customized as well. Okay, so let's see, where is it? Here it is. Right, turtle and shape. So you'll notice when I'm running this, for instance, right now, I get this little arrow-looking thing. However, I can actually change it to other shapes. So there are actually other shapes that are sort of built in. In fact, they mention here are the shapes that are already built into the package. Let me actually show you kind of my favorite. I like to use this here. Like so. So now it actually looks like a turtle. Right? And there we go. So that gives you an idea of some of the basics of the turtle package. I want to talk about actually a couple of other things as well. So, I mentioned the fact that this is that we're talking about this notion of a definite loop, right? So in the case of, for instance, drawing a regular polygon, we know how many times we're going to loop. However many sides there are, that's how many times we're going to loop. Are there other cases, or what types of things could we have where we allow for an indefinite loop? Okay, so what I'm going to do is I'll create. Let me create another project here. Actually, I'll do it this way. Copy, paste that in. Let's call it rand walk. Okay, so I left most of this stuff in here. Let me go ahead and just kind of change some of these things. So this is random walk. Most of this I can actually get rid of. Well, some of this here. Get rid of that. So here's the basic idea. What I want to do is simply have my turtle move forward some random amount. So let's say, okay, it can be as small as 1 and maybe as large as, well, how big is the screen, right? So the screen is basically 600. Technically, the way that this is set up. Oops, sorry, I actually didn't even run that. Okay, so let's talk about the coordinate system that's set up for us. Okay, so again, if we take a look at some of these methods, and you notice some of them kind of have shorter versions. So for instance, instead of typing out forward, you could say FD, backward has those. Let's look at these for a minute. So this go to, set pos, and set position. This allows you to specify an exact position for the turtle to move to. Okay, so instead of saying move forward this amount, what we could say is, go to or set your position to whatever the following is. So for instance, I could tell the turtle to set its position to 0, 0. Okay, so and I didn't run that. I actually ran the other one. So let me go over here and just run rand walk. Okay, and there it is. Notice, turns out 0, 0 is smack dab in the middle of the screen. Okay, so by default, 0, 0 is here. Okay, so what that should mean, for instance, is that roughly half of the screen size is the right edge of the screen. Oh, yes, sorry, screens. Let's do this. Window width. And there it is. Basically, he moved from here right to just beyond the edge of the screen, which I could see then by expanding that out, right? So I could do that, or similarly, I could do right, and we see we move all the way to there. So how do we move in the other directions? Again, suppose I do that. And there it moves off of that as well. Okay, so that kind of gives you an idea of the default coordinate system setup. The reason that I bring that up, right, is because that gives us a good idea of. Actually, I'm sorry, these are really moving too far. That really should be. Oops, sorry. That really should be half. Right, so it's moved so far up I can't even extend this that much. Really, this should be something like that. Right, so now notice it moves just to the top of the screen, and similarly, if I do that here, just to the bottom of the screen. Okay, so back to our forward, that basically means that when I move forward, I don't want to move so far forward that I'm going to sail off the edge of the screen. And so, so minimally I could have something like, all right, half of this, right? But then of course we have to realize, well, let's see, the height, the width is bigger than the height. So technically I probably want the height there to keep it on. And then again, I may actually want to even keep it kind of smaller than that. So let's say something around those things, etc. So I could actually write it in those terms. I could just have something along the lines of 100, right? And so you notice when I run this, he moves forward 100, moves forward some random amount between 1 and 100, right? Then let's have the turtle turn, and whether it's right or left, I guess it doesn't actually matter. I can say, okay, let's turn a random amount between 0 and 350. Oops, sorry, 359. Okay, oops. Random, sorry, randint. Right, so the turtle moves forward and has turned. Turtles move forward and has turned. So I want to loop this. Right now, I could certainly do something like the following. I could say, oh, okay, let's do this thing 10 times. Right, ends up looking something like that. So this is the idea of as the title suggests, it's a random walk, right? The turtle kind of moves forward a random amount, turns a random amount, etc. Might even want to sort of switch the order of those. So turn first, then move forward. Either way, that's fine, right? And so we get this this kind of random behavior. But perhaps I want this to kind of go on as long as it can. Right? And so what I mean by that is as long as the turtle is actually on the screen, I want it to keep doing this, right? So how many steps is it going to take before the turtle actually wanders off the screen? The answer is, for any given run, we don't know, right? And that's the point. The point is that a for loop here actually isn't that great of an idea. If I really want to implement that, what I want is an indefinite loop, a while loop, okay? So how do we go about doing this? So I got to do a couple of things first. Okay, so I need to be able to figure out where the turtle actually is. So for instance, let me just show you. Yes, import turtle. There, I've run the setup. Okay, and yes, that should come. There we go. Came at some point. All right, good. Print t dot position. Okay, so notice when I call t dot position, it gives me back a tuple. Okay, so the tuple has two values, one for the x value, one for the y value. I can separate those out in a couple of different ways. So one, I could say, oh, okay, give me the one at index 0, basically the first one, or give me the one at index 1, that gives me the second one. Of course, it's kind of hard to see that because they're both 0, so let's actually get the turtle to move a little bit, right? So if I say move forward, I don't know, 50, and then we print out the position, we can see that, oh, okay, we've moved basically 50 pixels from the origin, and our y value has not changed. Okay. Another way that we can actually play around with this is I can do something like this. I can say, here are two variables, x position and y position, and I'm going to set that to t position. So notice, I know that t dot position returns a tuple. I create my own tuple with two things, both variables that have not previously been assigned, and so now x position has the value 50 and y position has the value 0. Okay. So I'm going to make use of that in my random walk program. Okay, so the first thing I'm actually going to do is, where is that? Here we go. Grab this right there. Okay, and so I'll grab the x and y position of the screen. Then I can write a while loop that simply says, okay, as long as the x position is greater than, well, actually, let me do it this way because it might be a little bit easier to kind of understand and all of that. In the same way that that we can get the, I have not created that. Yes, you're right. Let's do these things here. There. Now I have the now I have access to the window. Right. So in the same way with position, screen size gives me back a tuple as well. Okay. So what I'll do is to simply say, all right, the and notice, it's giving me 400 and 300, not 800 by 600. It's basically giving me sort of half the width and half the height. Okay, so thus I've named it half width and half height. All right, so while the x position is greater than negative half width, okay. So in other words, as long as we haven't sailed off the left-hand side of the screen, then we're going to keep doing this. Right now, that's not the only case where we could basically sail off the screen. We could have things like, for instance, the following. I could say, and as long as it's the case that that the x position is less than half the width. Right, so that ensures that that we are on the screen both in terms of the left side and the right side. Right, then we want to make sure that we're on the screen in terms of the bottom and top. Half height and y position less than half height. Okay, so let's give this a try. Right, and there's the turtle scribbling along, scribbling along, scribbling along, and, oh, almost, yes, no. Yeah, he is, that looks like he's going off. Yes. Okay, the problem is, I get the turtle position once, and I don't update it inside the loop, right? So what I need to do is, I'll do, sorry, a D for duplicate, and then let's move this down into the loop. So after I've turned, after I've moved forward, let's update the position. And so now we should see something got pretty close. There he goes, right? Notice. And now the turtle basically is off the screen, and we've stopped. Right? Let's try it again. Yep, off the screen. We can make this a bit more interesting too. So we can add in that idea of randomness. That is the stuff that we have here. I'm going to actually add that into our code here. Except I don't want the fill color. I want the pen color to be random. So again, we can see, oh, okay, now each time we draw a line segment, we basically get a different color. And moving along, moving along, moving along. All right, that was actually a pretty long run. Now, suppose I wanted to do that multiple times. That is, I want to do those random walks a whole bunch. Okay, I can do that. Right, so I can wrap that in a loop itself. So I can say, okay, let's do this, say, 20 times. All of this stuff. Oop. That one did not indent. There we go. But notice, just after the for loop, what I do need to do is I'm going to basically tell the turtle to set its position to 0, 0. Okay, so let's see what that looks like. Right, now notice, I do actually draw this line back to the turtle starting point. And it might be the case that I don't necessarily want that to be the case. So actually I probably then want this in here as well. So I don't want it to actually draw a line when it does that, so I can, for instance, call the pen up method and follow that with pen down. So that is pick up the pen, move the turtle. So I will move the turtle without drawing a line. Then I put the pen back down so that we can continue on drawing. And so as we move through here, getting big long runs here. I may actually want to adjust the maximum for my forwards. There he goes. Okay, so he came back and so forth. Okay, now we can play around we can do all kinds of things here as well. We could do things like, just to kind of give you some ideas of different nifty effects that you can get with this. I could do something like the following. I could say t.stamp. So what that does is basically it sort of stamps down an image of the turtle at that particular location, right? So you notice we sort of get these looks like so. Okay. All these turtle splats and so forth. We could even, right? And if you really liked that kind of a stamping notion, suppose I just picked up the pen altogether, right? And then I have sort of these random turtles appearing all over the case. Now, basically, there's an outline color for them, which is the pen color, and the internal color of the turtle is black. So, I mean, again, we could kind of play around with that if we really wanted to. We could actually make the pen color and the fill color be the same, so then we get these kind of multicolored turtles. Just to show you what that would look like, so I'll do something like this. I'll create a variable called random color. And I'm going to grab all of this stuff, okay? Now, that's 3 separate components, but I can turn that whole thing into a tuple, because it turns out pen color will also take a tuple. So I could say, okay, set that, and also do that for the fill color, like so. And so that gives us this kind of effect, multicolored turtles moving along and all of that. So that would be, one kind of stylistic option for doing these things. I could have just said, okay, T dot fill color white, basically set it the same color as the background, and so now I get these little multicolored turtle outlines, like so. We could say, oh, okay, we like that, but we do in fact want the turtle to be drawing lines, and so we can get this type of thing, and just one more. So suppose I want to also vary before I make a move the width of the turtle that I use. So the width of this. So I can say, okay, set a random int. So let's go from 1 to 30. Right. So get some big thick lines, some perhaps smaller lines, etc. I'm going to bump this up a little bit. There we go. Now we get some kind of larger movements and so forth. Okay. Other fun that we can have with this, so notice, here when I'm doing a turn, I'm actually specifying any number across all the full range of possible values from 0 to 359. I can do things like this. I could say, right, so I could do right or left, it kind of doesn't matter. And I can even do things like this. I could say, okay, let's go from -60 to 60. So turning right -60 basically means turn left 60. Okay, so this will give you something kind of like that. And maybe try 150 there. Kind of. There we are. And so you can see, you can kind of get these sort of interesting little idea or artistic ideas. Again, let's kind of play around with the speed of the turtle. So let's say turtle speed 10, right? So there, now it's kind of drawing out faster and so forth, and kind of see from there. Okay, one other thing. So I happen to have in here this little file called Circle Fun. So you'll see this actually was taken from this resource online. Right, there's the resource itself. He calls it, if you take a look at that, notice there's the listing 1320, so you can kind of take a look. He calls this flower. Right, so if I actually run this again, let me come over to here and go ahead and run that. We get this this sort of multiple circles being drawn, right? So essentially drawing, so what is it doing? So range 0 to 360, 15, right? So let's go back and let's take a look at this. Right, so range, right, remember, range gives us a couple, oh, actually it doesn't, I guess. I don't really print that out in a nice way. Yeah. Let's see. Yeah, okay. Fine. Let's do it this way. For I in range 5, print I. Oops, that's not going to work because this is Python 3. Right, gives us basically the numbers 0 through 4. So what does this one give us? I wonder if I can do this. Can I turn this into a list? Yeah, there we go. And the same, so I could do list range of 5. Notice, right? So basically this last value says that's our increment value. So instead of by starting to count out by always counting by ones, here we say 0, 15, 30, etc. So that's essentially the particular values that we're going to get out of that, right? And so you can see we're going to draw a certain number of circles, and set heading says set your heading to that. Ultimately, we end up with this fun little flower design. Okay, and again, let me up the speed just so you can kind of see this. Right. Now notice, even at speed 10, maybe that's going a little too slow. I could try speed 0. Right, there we go. Okay, so we get kind of get that that notion. The other thing you can do is if you really are drawing fairly complicated designs, you can use the tracer method. Which basically says, essentially, this number here is how many drawing things to do before you update. Turtle doesn't have a tracer. Turtle doesn't have a tracer? What is it then? It's... Oh, yes. It's actually a package level method, like so. Right, and so there we go. We can kind of see that that drawn quickly. Now, the thing about this is that we can actually kind of play around with this too. So I'm gonna actually leave this one in and so I'll end up drawing that drawing on top of something else. So suppose, for instance, I take this whole thing and paste that in. Right, and let's just start with something kind of simple. So, for instance, let's just say we're going to set the fill color randomly. In fact, actually, we already have code that we've already written that code. So let's just paste that in, and go ahead and do. Oops, bad colors. Yes, you're right, because I need to set my color mode. Okay. Let's see. Fill color is... That was kind of strange, huh? Let me see. It almost looked like those are all the same color. Oh, right. They're all the same color because that's the fill color, not the pen color. There we are. If I do pen color, there we go. And then we draw over those using red. Okay. But I could do fill color. And then I could say t dot begin fill, t dot end fill, and now I get this. Okay. A bunch of filled in circles, and then we kind of draw over that using this. Okay, so again, I mean, you can kind of get a sense of how to kind of play around with these things, get interesting effects and so forth. Okay, so hopefully that gives you a good introduction to the turtle package. Once again, so when I have this this window open, if I close this here, it'll actually kill the or I can just kill the Python console myself, and you notice the window goes away. Okay, so again, hopefully that gives you a good idea of using the turtle module. You'll have some exercises for kind of playing around. If you have questions, obviously hit us up on Piazza. If you just found this on the internet, you can post something in the comments below.